Have you ever wondered how databases work or how information is stored and retrieved in an organized manner? Enter SQL, the structured query language. SQL is the fundamental language for interacting with databases. Think of SQL as the liaison between you and your database, the translator that helps you communicate what you want to do with the data. SQL stands for Structured Query Language, and as the name suggests, it's a language designed to structure, manage, and manipulate databases. It's the standard language used across the globe for these tasks. Whether you're dealing with a small personal project or a massive corporate database, SQL is the tool you'll use to talk to your data. You can use SQL to do everything from creating tables and adding data to them, to querying that data and making updates. It's a powerful language that's essential for anyone working with databases. Now that you know what SQL is, let's delve into some of its basic commands. So how do we create a database or a table in SQL, and how do we add or modify data in it? Well, let's start by creating a database. The create database command is your go-to tool for that. It's as simple as typing create database followed by the name you want for your database. SQL is a bit like a magic spell. You tell it what you want and voila, it happens. Now a database without tables is like a library without books, so let's create a table. The command is, you guessed it, create table. After that you specify the name of the table, and within parentheses you list out the columns, their data types, and any constraints you want to apply. It's like designing the blueprint for your data. But what good is a table without data? That's where the insert into command swings into action. It's like the librarian who puts the books on the shelves. You start with insert into, followed by the table name. Then, in parentheses, you list the columns where you want the data to go. After that comes the values keyword, and in another set of parentheses you list the data, in the same order as the columns you just specified. But wait, what if you need to change some data that's already in the table? No problem. The update command has got you covered. It's like a librarian who realizes they've put a book in the wrong place and needs to correct it. You start with update, followed by the table name. Then you use the set keyword to specify the column and the new value. If you want to update specific rows, you can use the where clause to specify the condition that the rows must meet. And there you have it. The basic building blocks of working with data in SQL. The create command to make databases and tables, the insert command to populate them with data, and the update command to modify the data when needed. With these commands you can create a database, insert data into it, and update it as required. Now that we have a database with data in it, how do we retrieve and organize this data? Let's dive right into that. To fetch data from our database, we have an invaluable tool called the select command. Think of it as a spotlight, highlighting the data you want to see from a particular table. Say we have a table called employees, and we want to see all the data in it. We just write select. Here is a wildcard, indicating we want all the columns. But what if we only want specific columns, like the names and salaries of the employees? In that case, we'd specify those columns in the command like so, select name, salary from employees. It's as simple as that. Now imagine we need to filter our results, perhaps to find employees earning above a certain amount. This is where the where clause comes into play. It's like a gatekeeper, only letting through the data that meets certain conditions. For instance, to find employees earning more than $50,000, we'd write select name, salary from employees where salary, 50000. But let's take it a step further. Say, we want to view these high-earning employees, but we'd like to see them in order of their salaries from highest to lowest. This is where the order by command shines. It's like a sorter, arranging our data in a sequence we specify. So we'd write, select name, salary from employees, where salary, 50000 order by salary desk. The desk keyword here indicates we want a descending order. For ascending order, we'd use ASC instead, and there you have it. The select command to retrieve data, the where clause to filter it, and the order by command to sort it. All these SQL tools working together to fetch, filter, and sort your data. A neat little toolbox for your database needs. In this way, you can retrieve specific data from your database and sort it in any order you prefer. But what if our data is spread across multiple tables? How do we get a unified view? This is where joins in SQL come into play. Joins are like the glue that holds your data together when it's scattered across different tables. They allow you to pull together disparate pieces of information to create a comprehensive view of your data. Think of it like a jigsaw puzzle. Each table is a piece of the puzzle, and joins are the mechanism that helps you put these pieces together. So let's delve into the world of SQL joins. The most common type of join is the inner join. This is like the intersection of two sets in a Venn diagram. It returns rows that have matching values in both tables. So if you're trying to find employees who are also customers, an inner join would give you that information. Next, we have the left join. This type of join returns all records from the left table, and the matched records from the right table. If there's no match, the result is null on the right side. Imagine you want to see a list of all your products, and if they've been ordered, a left join will give you exactly that. Then comes the right join. It's the mirror image of the left join. It returns all records from the right table and any matching records from the left. If no match, the result is null on the left side. This could be useful if, for instance, you want to see all customers and any orders they've placed. Lastly, we have the full join. It combines the results of both left and right joins. This means it returns all records when there's a match in either left or right table. When there's no match, the result is null on either side. In a nutshell, joins are a powerful tool in SQL that let you bring together data from different tables based on a common column. They're like the bridges that connect islands of data, enabling you to see the complete picture. Joins allow us to combine rows from two or more tables based on a related column between them. Sometimes we might want to group our data based on certain columns. How can SQL help us with that? Enter the powerful group by command in SQL. It's like the point guard in a basketball team, orchestrating movement and creating opportunities. But, instead of players, it's handling your data. It's a crucial tool when you need to group data based on certain columns, and it pairs perfectly with aggregate functions. Think of your data as a bustling city. Each row is a building, each column a street. Now imagine you want to get a bird's eye view of this city. You want to see how many buildings are on each street, or perhaps the tallest building on each street. This is where the group by command comes into play. Here's how it works. The group by command organizes your data into groups based on the columns you specify. It's like a sorting hat, segregating your data based on parameters you set. But it doesn't stop there. When paired with aggregate functions such as count, AVG, max, min, and sum, it can provide summary information about each group. Let's break it down. The count function will tell you how many rows or buildings are in each group. AVG will give you the average value of a specific column for each group. Max and min, as their names suggest, will provide the maximum and minimum values respectively. Finally, the sum function will add up all the values in a specific column for each group. It's like having a personal tour guide for your data. You can find out how many rows belong to a certain category, or what the highest or lowest values in each group are. It's incredibly useful when you need to analyze and interpret large amounts of data. But remember, the order in which you list your columns in the group by clause matters. SQL will group your data based on the order of the columns listed, from left to right. So think of it as your data's GPS. You set the destination and it'll get you there. With the group by command, you can group your data in meaningful ways and get a summary view. With this powerful tool in your SQL toolkit, you'll be able to navigate your data city with ease. In just a few minutes, you've learned the basics of SQL and how to manipulate and retrieve data from databases. We've taken you on a journey through the fundamentals of SQL, starting with the creation, insertion, and updating of records. We then moved on to selecting data using the where clause and ordering it with order by to make sense of our data sets. We explored the concept of joins in SQL, a powerful tool that allows us to combine data from different tables. And let's not forget group by, which enables us to categorize our data, making it easier to analyze. Each command has a unique role, but when used in combination, they can unlock the full potential of database manipulation. Remember, the key to mastering SQL lies in practice and continuous learning. With these basics of SQL, you're now ready to explore databases and retrieve valuable insights from data. Keep practicing and happy querying.